Welcome to this manufacturer showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with newer emerging technologies meant to facilitate decarbonizing our building stock and applicable across entire portfolios. All sessions will be recorded and available upon request, and slide decks sent to all attendees. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to your questions. We ask that you go on mute until then. And now it is my pleasure to present Bing Dong of Syracuse University and Claudia Piacenza and Trofimo Sai of Clivet. Bing?
Thank you, Saul. Thank you very much. Good afternoon, everyone. I'm Bing Dong. I'm a PI for this project. So today I'm going to introduce two products from Clivet, Italy. One is called Easy Home, ELFOPack version 2, and ELFOStorm. For the first project, it is an integrated domestic hot water heating, cooling, and ERV solution specifically for low-rise multifamily residential building. It's called Easy Home, and also called ELFOPack version 2. So this project has me as a PI, and also Jason Zhang from Syracuse University, and Yue, a student from Syracuse University. And the Clivet team, I can see from here, including Enjoy, Yuri, Claudia, David, and Stefano. And also, Ten Engineering is our engineering team. So the project goal is to adapt the Easy Home, the ELFOPack unit, which is already developed in the Europe, made by Italy, and for the New York State low-rise multifamily residential building and climate changes through the testing, evaluation, development, and the demonstration. So the performance target is to achieve 50% energy reduction compared to the conventional forced air system, and 15% energy savings compared to the conventional heat pump system, at a very significant lower equipment installation and operation cost than other conventional systems. So in order to do that, we first test out ELFOPack version 1.0. This system is shipped and tested in the Syracuse University base lab. And the idea is we will monitor through the Internet of Things, monitor people's presence in each individual home, and look at presence patterns, also the consumption patterns, so that we can do advanced controls, airflow controls for this system into different rooms. First of all, we put this system, as you see from the right side image, into the chamber test, and we look at heating and cooling capacity, and also COPs. So this is a sample results from our heating COP, and it's between at a different outdoor temperature, which shows on x-axis, and it's between 3 and 4. As a value of between 3 and 4. On average, is about 3.5 for the heating COP. And this is testing results on the base lab. So the base lab is a 2-story home, and in this case, we modify the first floor of base lab and mimic it as a real 2-bedroom apartment in New York State climate. And we install this ELFOPack 1.0 in this test home, and to look at the real-time indoor temperature, energy consumption, and also indoor air quality. And this shows one example that from the real-time data, it shows this device can meet the temperature set point requirement for the New York State weather. And both bedroom, bathroom, and also large living room indoor temperature are well maintained within the temperature set point. Okay, now I turn this to Claudia. Based on our testing results, Clivet is developing the modified existing ELFOPack system into ELFOPack version 2 called Easy Home. Claudia, please.
Yes, hello everybody. I'm now presenting very quickly the main feature of Easy Home that also has been told you is the product that we are now working on. So it is a product now on development. You see the appearance of the unit on the right and also in the table the main features of the product. So it is basically Easy Home is a air-to-air heat pump for air conditioning and domestic hot water production. It is for a residential application. The capacity both in cooling and heating is about 5.5 kilowatt. The airflow goes from 400 to 1000 cubic meter per hour, and the refrigerant is R454C, that is a refrigerant with GWP lower than 150. The unit is a full inverter unit with one inverter compressor and two EC, so variable speed fans. Also on the supply side, the supply fan can provide 200 Pascal of available static pressure. The domestic hot water tank has a capacity of about 200 liters. The size of the unit you see in the table is 2 meters in height, 1.1 meters in width, and 0.6 meter in depth. The installation will be indoor. And the functioning limits are from -20 up to 45 Celsius degree. If we go to the next slide, we can see the configuration of the unit. So one of the main features of this new product is that the ventilation unit and the domestic hot water module can be installed separately. The domestic hot water module can be installed up to 15 meters of distance. The ventilation unit works as a air conditioner, so basically the unit recirculates the internal air, but at the same time a portion of fresh air can be supplied to the internal ambient to renew the internal air. If we move to the next slide, we have more details about the two modules. So for the ventilation unit, we will have filters both on the supply and on the exhaust side. On the supply side, as optional, also an electrostatic filter can be installed. Also, there will be the humidity management, so the chance to dehumidify the air. Also, as optional, CO2 sensor will be available for the renewal rate, also energy and capacity monitoring, and the chance, of course, of having free cooling and free heating. For the domestic hot water module, that is about, as told before, 200 liters of capacity, the module will have inside both the expansion tank, the mixing valve, the safety valve, the electric heater as well, and the electronic anode for tank protection. And there will be also the chance to have a contact to activate the heater with the photovoltaic panels. Also, in the next slide, we can see the system that Clivet will provide. So basically we will have the user interface, what is also called the HMI, that can be mounted on the unit or installed remotized, and it is the user interface. The user interface will be also connected to the app Clivet Eye, that is a Clivet app, and there will be also the chance to connect the unit to the IoT supervisor control for energy that could be able to manage some thermostat directly installed in the different rooms of the house.
Okay. Thank you, Claudia. That's for the first project. So now let's go to the second project, which is a modularized heating pump system. And this is integrated heating, cooling hot water system for middle-rise apartment building. So the project team is from tenant engineering. So Lo is a PI for this project, and me and Jason and Tristan are co-PI on this project, and also including Clivet team. So the idea of this project is to retrofit existing middle-rise apartment building with a modularized heat pump system. Works as a heat pump plus a domestic hot water generation. And it is supposed to be 60% more efficient than a traditional package unit, like rooftop units, and 40% space saving due to the modularized design. And then we also integrate the ELFOFresh, which is ERV system, which is innovative ERV system, purification system, working with indoor fan coil unit. So this is our overall idea. And this project is just started. Now I'm turning to Clivet Tromfin to introduce this product in detail.
Thank you, Bing. Let me present myself. My name is Trofim, project leader in Clivet for the modular heat pump. Let's have a quick introduction to this product. First of all, this product is already developed for the European market and widely spread in the Europe. Right now, we are working on it to adapt for the New York market, New York State market especially. And this product will be for an air-to-water light commercial application with a cooling capacity up to 90 kilowatt and using a sustainable refrigerant like R32. Since for the New York market is required a 15 horsepower for a circuit, this unit will be a double circuit full inverter compressor up to 15 horsepower and full inverter fans. It's for an outdoor installation. The configuration for this unit can be a standalone, modularity, or a domestic hot water production. In addition, there will be the possibility to have on the same time the production for the heating and domestic hot water production. On the next slide, we can see the main feature that this product will have once will be available on the market, which will be the Modbus connection, IoT monitoring. Then we will have several noise management of the unit, since it can be a critical point for in some times of the day. The unit will have the possibility for the scheduling, an adaptable curve for the set point, and as we said, the modularity of the whole system. On the next slides, we can have a quick in the modularity two pipe system layout. This actual configuration is already available on the European market. As you can see, there are some space between the units, but in our mind is to have the units together in order to reduce more the space between the necessary space for the installation. So the systems will manage up to 8 units in contemporary, loading unloading function for efficient and rotation program. As we said, space reduction will have the possibility to have a modular kit for a fast installation and flexible system for a redundant solution. On being, I would say that thank you for the support.
Yeah, thank you, Chavi. So next one, I want to specifically talk about the ELFOFresh EVO system, which is a thermodynamic heat recovery ventilation unit. Will be integrated in this project too. So I pass to Claudia again.
Yeah, thank you. Okay, ELFOFresh EVO, you see in the picture, it is a thermodynamic heat recovery ventilation unit. It is a full inverter unit with both inverter compressor and inverter fans. has a capacity up to 2.5 kilowatt and an airflow that goes from about 100 to 300 cubic meter per hour, and the refrigerant is R32. It is 0.3, about 0.3 meter in height and 1.1 and about 1 meter in width and length. It is for indoor installation. Also, for this unit, it can be installed an electrostatic filter as option, and the functioning limits goes from minus 20 to 45 degrees Celsius, and the maximum sound power is 45 dBA. In the next slide, I think it will be more clear how the unit works. So basically, it works with fresh air, with the outside air. The outside air is supplied to the indoor ambient, and the indoor air is completely thrown off. You see also that maybe from the picture is not really clear, but the structure of this unit is in EPP material, so plastic material. And so the unit is a lighter unit compared to a metal structure. Also, in the next slide, we have some more details about the features of the unit. So, as said before, it can work up to minus 20 Celsius degree. It has a structure in plastic material. The fans are constant airflow fans with 120 Pascal of available static pressure. Also, the humidity can be managed on the supply side. It also has a drain pump with the flow switch for the condensate. The air connection that were shown in the previous picture are 0.2 meters of diameter, and also the duct can be turned in the most convenient position. And as I said before, as optional, it is available an electrostatic filter. In the next slide, we have also shown a comparison between ELFOFresh and passive cross-flow units, both in heating and in cooling. What we see, for example, from heating, in the red line, dotted line, we see the set point temperature, I mean the temperature of the indoor ambient that we want to keep for the internal comfort. What we see is that in the outdoors air range, basically a cross-flow unit is not able to provide, to supply a temperature of 20 degrees, while the ELFOFresh in all the external air range can provide a supply temperature even higher of 20 degrees. It means that with ELFOFresh, or maybe it means that with the passive cross-flow unit, for sure an additional unit has to be installed for supply the thermal load, while with the ELFOFresh, this additional unit can be not installed, or if installed, its effort is reduced. And the same is in cooling. We see that with ELFOFresh can provide a supply temperature lower than the comfort one, that is in this case about 25 degrees, while the cross-flow unit with passive heat recovery is not able to provide the comfort temperature. And this is for sure due to the benefit of the thermodynamic heat recovery. That's it.
Yeah, thank you for your attention. And this is our presentation. If you have further questions, you can email me or Claudia or Chunfi, which I'll provide later, and allow for those two projects. Thank you.
Thank you.
Thank
Great.
you.
Thank you so much. So if anyone in the audience has a question, now is your time. You can unmute yourself And then once your question is addressed, if you could go on mute again, that would be great. So if anyone has a question, please, now's your time. Bing, I'll begin with a question then. In terms of the performance results for the initial system that you've now gone through testing, how do they compare with its deployment in Europe for comparable climate zones? I know Syracuse is ASHP Climate Zone 5, almost up to 6. So I'm curious in those conditions what you found compared to Italy or perhaps other European countries where the system's been tested.
Yeah, so based on our base lab testing, which we installed this system in the two-bedroom mock-up setup, we actually found the results are pretty consistent with what happened in Europe. We add a preheating system for this device in the extreme cold weather. So the original system is designed at temperature lowest as minus 4 degrees outside, but due to the cold climate in upstate New York, the design temperature is minus 15 degrees C. So we add a preheater into the system to heat our temperature around 0 degrees C before it enters the system. And we found out the overall COP and also energy consumption is pretty much aligned with what was tested in Europe, and we are very happy with the results. And also the total COP is between 3 and 4. That's very good. Yeah.
So the COP performance is with the preheater installed.
Yes, it's with preheater installed. Yes, it's very much aligned.
Got it.
Yeah. Mm-hmm.
Great. Any questions from the audience? All right, I'll ask one more before we end. In terms of the price points that you're targeting for the New York market, particularly on a per dwelling unit basis, can you speak a bit about that once these are going to be ready for introduction and what your ultimate price point is that you're targeting once you scale up in the US market?
Yeah, I can speak about this based on my projection, and I welcome Clivet side to chip in as well. So the original for demonstration, we are expecting that this is around $13,000 US dollars per unit. That's just for demonstration purpose. But when to scale up, we are imagining the price will significantly cut down by clear to close to half or 40%. So imagine that the final price will around $6,000–7,000 per unit for the New York State market. Yeah. That's my kind of projection for the future when we have a larger scale deployment. I don't know if
and is that,
yeah, go ahead. So
I was just going to ask, is that per dwelling unit, serving per dwelling unit, or is that per mechanical unit that you're installing?
That's for per energy port, which is per unit. Yeah.
Okay.
Yeah.
Yeah. If Clivet wanted to add anything.
I'm just asking if Cliff side want to add anything on that. If you don't have anything to add, yeah.
Hello.
So we'll open it.
Yeah.
Oh, please go ahead.
So actually, this product is still on evaluation right now. In our side is not on a cost evaluation or a price for the New York State. We are on the phase where we just looking to develop the product and check how we can place on the New York State market. Speaking about the modular heat pump, right now we don't have a fixed price for the market, but again, it's according to the New York State market request, and we can evaluate some price on the next month or on the next period of time.
Yeah.
Great. Thank you.
Thank you. Yeah.
Last call for questions from the audience. All right. Well, Bing, Claudia, Trofim, thank you so much for your presentation. All who attended, thank you for your attendance today. And this is the last in our series for the time being. So we're very grateful that you attended this and our other sessions in the series. And we wish you a fine day.
Thank you.
Thank you.
sir.
you.
Yeah. Thank you all.
Very much.